Hello and welcome back to my Desynced programming tutorial series. This episode is dedicated to recycling. The first script that I'd like to show you makes it easy to spread your recycling resources across the map. I find this really beneficial compared to a centralized resource recycle because I find that after a battle, you want your recycling facilities close by. If it was a decisively good battle, then you have a lot of loot to store. And if it wasn't, then you want those components that are now on the ground to quickly be built back into buildings. And so having these recycle drop spots nearby can speed that process up considerably. Let's take a look inside. Now this is just a normal storage location, and it has a behavior that announces it as a recycling drop-off location. Inside that behavior, there's a 5-tick wait just to reduce load. This is not a very quick script. Nothing in here needs to happen quickly, so no need to cook the processor. Then it checks to see if there's any entities within range that can make use of its resources that it has on hand. Right after a battle, this is critical. So what it does is it loops entity range for construction. It loops the recipe ingredients for that. And anything that it has on hand, it tries to transfer. Now, there's no need here to see if you actually have that recipe ingredient, because if you do, this command will succeed and order the transfer. And if you don't, it will just silently fail and move on to the next thing. So checking ahead of time whether you'll succeed is just a waste of time. Afterwards, it orders everything remaining to shared storage. Shared storage is great for manufacturing items, so it's the input to each of my facilities is a shared storage location. And then the part that actually does the announcing is we check space, and if we have room, we announce green for recycle, and if we don't have room, we announce nothing by nulling out the signal field. Now, I'm using a radio receiver for no solid reason other than it's a stack 1 item, which means that even if I have radio receivers in the inventory of this logically is the same thing as asking if there are any empty slots left in this building. So I have this next to a simulated battle, and let's take a look at the drone that is going to go ahead and clean this all up. Now, this is the retrieve and rebuild script. Let's take a look inside, and I have this on a scout, and I've prepared it with a full inventory. It's currently powered on but turned off so that I can activate it when ready. Inside of an unlock lock block, what I first do is check the nearby construction to see if I'm able to provide anything from the local storage. This is the same strategy that we just had in the recycling center. However, this script runs constantly and moves all over the place. And so whereas in the recycle center, I wanted to save compute resources, in this one, I'm using lock and unlock blocks to take as much compute power as I can to make this faster. So this again should hopefully replenish anything nearby. Now I don't attach this to the signal network because I don't want this to do any long distance transfers. I only want it to look in its immediate space. This is going to increase the speed at which I do rebuild, and it's going to decrease the speed at which I do opportunistic build of things across the map, which I think is a fine trade-off. Now, the next thing it does is look for dropped items. The first way it looks for dropped items is through its standard getClosestEntity, which checks its own visual range. And then it also checks for items using the signal tower network. In either case, whether it finds it from its own vision or it finds it from the signal tower network, that value is going to be copied into parameter P1, dropped item, and then it's going to do this subroutine. We're going to check for space to see if we can have that item in our inventory. And if we can, we'll go ahead and pick it up. If we can't, then what we'll do is null out our drop-off location, scan through to see if there are any drop-off locations nearby, and if so, drop it off. Now, the reason we null it out here is that if we previously found a nearby recycling center and then it became full, well, that would still be in P2 if we didn't null it out. And so even though it's now saying, hey, I can't accept items, this would be a place where it would remember, but you used to accept items. And so this is what makes that work. Let's see it in action. So I'm going to turn on the behavior. And it's going to start dropping off items in its recycle drop box because it was already full and unable to pick up anything. It has this entire field full of scattered resources to draw from. And just to make the more interesting behaviors more visible, I'm going to cheat and tell it, you have to go up here first. Nope, come on. Let's try that again. I'm going to cheat and say, go up to this interesting location. Hit play. Now it picked up the simulated battle damage and immediately put it in the construction locations. Now again, I've just added 2 silly buildings nearby just to make this more visible. But you can imagine that that would be quite beneficial if you have a large-scale battle there. Now it's going to continue on its way. At some point, it's going to fill up this recycle drop point. It's going to say, hey, I can't do that anymore, and go back to these recycle drop points closer to base. And for the last part of this video, I want to go back over these 2 pieces of code with the sudo Python at the same time. Please let me know in comments if this is at all helpful. I find it makes it easier for me to organize my thoughts this way, and also provide a little bit of structure. So we have 2 nested loops, and I find that the Python syntax makes that nesting much more obvious than the Desynced syntax. We're going to loop over the entities in range, and within those, we're going to loop over their ingredients. Oops, that should be an A. And we're going to order the transfer. Anything remaining, we're going to order to shared storage. And then we're going to check space for item. And I've said explicitly DummyItem here, even though I use our radio receiver, and signal either green or null. And then again, for the retrieve and recycle script, we're going to start with this unlock lock block, which I'm using the with syntax from Python to describe, which again, I find making it have this block out notation makes it easier for me to remember where my lock has to come after an unlock. So we're going to loop over the entities in range for anything that is under construction. We're going to look at their recipe ingredients, order those transfers, and order the drop-offs. From there, we're going to start looking for our dropped items. The first way we do that is with a get closest entity followed by a match, just to make sure it's not a null. And even though I'm not actually using subroutines, I'm going to call it subroutine pickup and drop off. Then we're going to do the same thing in another unlock lock block, where we're going to use the loop signal match and the select nearest. From there, we're going to call the subroutine pickup and drop off. And the subroutine pickup and drop off is pretty straightforward. Again, it's to check space for items. Let me just move this so you can see it. So we're going to check space for items, pick them up, and if we don't have enough space, then we're going to go ahead and null out what we were looking for our drop off location, and then go and drop off those items. All right, thanks again, and let me know if this is useful or interesting.